Another example. Consider two continuous RVs X and Y with joint probability density function, joint probability density function f xy being equal to c y squared from 0 less than x less than 2, 0 less or equal to y less or equal to 1, 0 elsewhere. What do we want to obtain here? Roman 1 show that C is 3 over 2. Roman 2, find the probability of y less or equal to a half. Then Roman 3, determine Roman 3. Find probability of capital X plus capital Y less than 2. Like that. So that's what we have to dissect in this case. So Roman 1, we want the value of C, the constant C. That one is very easy. Solution. So for Roman 1, we use the property that the integral over all x, all y, f x y dx dy is a 1. Then we substitute. So this should imply that we are integrating from, you see, we have x ranging from 0 to 2, and also y ranging from 0 to 1. What is the function? Cy squared. The limits I have 0 to 1, 0 to 1 first. 0 to 1, that is dy followed by dx. This should equate to a 1. So I evaluate this double integral. So we shall have the integration from 0 to 2. So if we integrate cy squared, so we shall have c y power 3 over 3 from 0 to 1 dx equals 1. So I feed in the limits of integration. I have been integrating with respect to y. Okay. I feed in the limits of integration. So I have from 0 up to 2. That is c 1 power 3 over 3 minus 0 dx equals 1. And this is the same as, I hope you can see that a third is a constant. A third integration from 0 up to 2 c dx equals 1. Like that. So we have a third cx 0 up to 2 equals 1. So this implies that we have a third 2c minus 0 equals 1. And this should mean that c is 3/2. Was that what was required? Yeah. It should mean that c is 3/2. Then find the probability of y. Now you see y is fixed. Hope you remember from the discrete case. Y is fixed. So what is the Roman 2? Roman 2, I want to evaluate probability of y less or equal to a half. You see, y is less or equal to a half. But remember, from the way how the distribution was defined, we're having from 0 up to 0x. X was ranging from 0 up to 2. X was ranging from 0 up to 2. Then y was ranging from 0 up to 1. Now here, y has been fixed. We must hit up to a half. So now this should transform to this. No. So x remains the way it is. X remains the way it is, like that. It is varying. And y has been fixed from 0 strictly up to a half. So we change from this. We change from 0 up to 1. Change from 0 up to 1 to 0 up to a half. Therefore, the probability of y less or equal to a half, this is equal to the integration from 0 up to 2, x remains, then y from 0 up to a half, fx y dy dx. And this is equal to from 0 up to 2, 0 up to a half. What is the function? The function was c times y squared. C times y squared. C is 3/2 times y squared dy dx. So I manipulate this and get the value of the probability. So from 0 up to 2, so we integrate, we shall have 3/2 times y power 3/3. These are limits of y. So from 0 up to a half. The x is still there. So I substitute those limits. This goes with that. Substituting the limits, we have from 0 up to 2. Substituting the limits, we shall have a half times a half power 3, then minus, when I substitute a 0, dx. Inside there, I get 1/16. 1/16. So this is integration from 0 up to 2, 1/16. 1/16 dx. This is equal to, when you integrate that, this is 1/16 x 0 up to 2. It is easy to see that this is 1/16, 2 minus 0, 1/8 as the required probability. Then for Roman 3, they wanted us to find, where's Roman 3? Probability of x plus y. X plus y less than 2. Probability of x plus y less than 2. Roman 2. Roman 2 want probability of x plus y less than 2. Now let me first explain this, but still it is obvious. It's obvious. Why? Anyway, what did I have previously? Previously, I was having 0 less or equal to x less than 2, then y 0 less or equal to y less or equal to 1. I must now change one of the two. So you decide. The condition which has been given is x plus y less than 2. For simplicity, let me make, you can either make y or x the subject. No worries. You can decide to make either x or y the subject. So if I make, what should I make the subject? If I make x the subject, then I have x less than 2 minus y. Now you see, after making x the subject, it's like now this x is fixed. X is fixed. So implying that if I make x the subject, it implies that I'll have this and 0 less or equal to y less or equal to 1. But that x was starting from 0, so I'll have 0 less or equal to x less than 2 minus y, and also 0 less or equal to y less or equal to 1. Alternatively, one can also have this. Still, this is what I've said. The question initially was the probability was defined over this region. But you want the probability that x plus y is less than 2. Now make y the subject. Y is less than 2 minus x. It's like now you fixed y, but y was starting from 0. So it's like we shall have from 0 less or equal to y less than 2 minus x. Then what is x? X remains like that. So you choose one of those two. You choose one of those two. Yeah. Now let me take this. Yeah, you can also do that and verify whether the answers will be same. So what is that probability? That probability is equal to the integration start with limits that are not having constants. So 0 to 1 followed by 0 followed by 0 to what? Followed by 0 to 2 minus y f x y. These are limits for dx dy. Yeah.